Good morning everyone. The topic of my presentation is IR spectroscopy. Introduction. Infrared spectroscopy or vibrational spectroscopy is concerned with the study of absorption of infrared radiation which results in vibrational transitions. Infrared radiation refers broadly to the part of the electromagnetic spectrum between visible and microwave region. Principle. When the frequency of the IR radiation is equal to the normal frequency of vibration, the molecule absorbs IR radiation and a peak of absorb. Every bond or portion of a molecule or functional group requires different frequency for absorption. Theory. IR radiation does not have enough energy to induce electronic transitions as seen with UV. For a molecule to absorb IR, it must be accompanied by a change in dipole moment. Reasons of wavelength range. There are three reasons. First, very near IR, overtone region, 2 to 2.5 μ. Second, near IR, called vibrational region, from 2.5 to 25 μ. Third, far IR, known as rotational region, from 25 to 400 μ. Hooke's law gives the formula of frequency and reduced mass, where mu bar represents the frequency which is equals to V bar represents the frequency which is equals to 1 upon 2 pi root over k upon mu, and mu is equals to m1 m2 upon m1 plus m2, which are masses. Types of vibrations. There are different types of vibration. First, stretching. Then stretching vibration is further divided into two categories. The first is symmetric stretching vibration and the second is asymmetric stretching vibration. Second type of vibration are bending vibrations, which are further classified into two types: in plane bending and out of plane bending. In plane bending is again categorized into two categories, which is scissoring and rocking. Out of plane bending also has two types, which are wagging and twisting. The below diagram explains very well the symmetric stretching, symmetric bending and symmetric bending vibration and twisting. So in both outside, when the both outside atoms move away from or toward the center, then it is symmetric stretching. When one moves to other side, it is bending, and scissoring in case when they are opposite, and twisting in case when one is opposite to the another one in the different direction. Asymmetric stretching vibration, as one atom moves toward the center and other moves away. Asymmetric bending vibration in a plane, rocking. Asymmetric bending vibration out of plane, wagging. Factor influencing vibrational frequency. First, symmetry. Symmetric compounds do not possess dipole moment and are IR inactive. Example, symmetric acetylene. Second, Fermi resonance. Fermi resonance results in an unexpected shift in energy and intensity of the bands. Example, the overtone of CH deformation mode at 1400 cm inverse is always in Fermi resonance with the stretch of the same band at 2800 cm inverse. Third factor is hydrogen bonding. Hydrogen bonding brings about remarkable downward frequency shift. Intermolecular are the broad bands and intramolecular are the sharp bands. Fourth factor is electronic effect. Electronic effects such as inductive, mesomeric and field effect may cause shift in absorption band due to change in absorption frequency. Example, inductive acetone at 1715 cm inverse and chloroacetone at 1725 cm inverse. Mesomeric acetophenone 1693 centimeter inverse, and para amino acetophenone 1677 centimeter inverse. Fifth factor is bond angles. Difference in bond angles also lead to the changes in absorption bands. Example, the following ring strains shows very well the example of bond angles. Instrumentation. The main parts of IR spectrometer are as follows. First, IR radiation sources. Second, monochromators. Third, sample cells and sampling of substances. Fourth, detectors. Source is as in sample, which are then monochromators, then the detector, and then we read out. Sampling of liquids. Liquids sample can be sandwiched between two alkali halide plates, which can be of NaCl, KBr, CF2. This sample cell thickness is 0.01 to 0.05 millimeter. And the following is the diagram. Sampling of gases. Here gases sample is introduced into a glass cell made up of NaCl. Very few organic compounds can be examined as gases. Example, 1,4-dioxane. The next topic is dispersive IR instrument. Dispersive IR instruments are introduced in 1940s. Double beam instruments are mostly used than single beam instrument. In dispersive IR, sequential scanning of wave numbers of light takes place. The next topic is applications of IR spectroscopy. The first application is identification of an organic compound, which is identified to measure spectrums, and node to samples will have identical IR spectrum. Second application is qualitative determination of functional group. The presence or absence of absorption bands help in predicting the presence of certain functional group in the compound, like type of band, the triple bond between C and N, carbon and nitrogen. The intensity is medium and the wave number is 2260 to 2220. Then there are several examples: triple bond between carbon and carbon, single bond between carbon and carbon, bonds between carbon and oxygen, oxygen and hydrogen, nitrogen and hydrogen, carbon and hydrogen, etc. Next is fingerprint region. Absorption band in the region 1500 to 500 centimeter inverse. Useful for establishing the identity of compound. It consists of first region 1500 to 1350 centimeter inverse. Appearance of doublet near 1380 centimeter inverse and 1365 centimeter inverse shows the presence of 3-degree butyl group. Second region 1350 to 1000 centimeter inverse. All classes of compound or alcohol, esters, lactones shows absorption in the region due to carbon-oxygen stretching. Third region below 1000 centimeter inverse. This region distinguish between cis and trans alkene. The fourth application is identifying the impurities in a drug sample. Impurities have different chemical nature when compared to the pure drug. Hence, these impurities give rise to additional peaks than that of the pure drug. By comparing these, we can identify the presence of impurities. Next and the last topic is limitation of infrared spectroscopy. By IR spectroscopy, it is not possible to know the molecular weight of a substance. Second, it does not provide information of the relative positions of different functional groups on a molecule. Third, from a single IR spectrum of an unknown substance, it is not possible to know whether it is pure compound or a mixture of compounds. So it was all about IR spectroscopy, where we have discussed its applications, factors, some terms, fingerprint regions, the stretching, the vibration, then its type, stretching, bending, then further their types, and introductions, also the principles. Thank you.